Good day, guys. Let's get another problem of center of gravity. We are told to sketch the graph of x squared over 25 plus y squared over 4 equal to 1. So that is one important thing for me. I underline and show the area in the first quadrant. Those are key things I underline, bounded by the graph and the lines x equal to 0, x equal to 3, and y equal to 0. Also show the strip when the generated area rotates about the x-axis. So once I read that problem, that is what is important to me. Then from there I'll calculate the volume, then I'll look at the x-coordinate of center of gravity. So I'll start with the important information that I've underlined. I see the graph of x squared over 25 plus y squared over 4 equal to 1. That's the first thing. Then I've seen the graph of y equal to 0, x equal to 0, x equal to 3. So those are the graphs I think I'm seeing. Then I'm also told about first quadrant area. So that means that is where I'm putting my strip on the area I'm shading. Then I'm told about x-axis rotation. So when I read the problem of volume, this is how I extract my information. So I see that I've got 4 graphs here. So keep understood. We have to always know that when you have 4 graphs, 2 are your limit. So I'm picking my limit all from the same axis, which is the x. You can pick limits from 2 different axes. So immediately I pick limits from the x, it's already giving me an idea about the strip, that my strip must touch the x-axis. So I'm anticipating the vertical strip. Now, you must not forget that y equal to 0 is another name for the x-axis. X equal to 0 is another name for the y-axis. So by putting the xy plane, I'm done with those 2 graphs. So we can go and put our xy plane. This is our xy plane. So I'm already done with those 2 graphs. Then I need the graph x equal to 3. It touches the x-axis only at 3. I can choose where I want to put my 3. If I choose to put my 3 here, then I'm also done with the graph x equal to 5. So what I'm left with is the first graph. So that first graph, looking at it, if you see x squared and y squared appearing in the same graph with a positive sign, then it's either you are going for a circle or an ellipse. For it to be an ellipse, you see the divide with different numbers or the multiply with different numbers. If these numbers were all 25 or all 4, this would be a circle. But since they are different, it is an ellipse. And those numbers can either be divided or multiplied. So that's the equation of an ellipse. So to sketch an ellipse, it's very simple. All you need to do is go to the equation. You see that the equation has x and y, so it means the graph must touch the x-axis and the y-axis. So if I want to know where it touches the x-axis, for example, I need to go there, make y 0. If I make y 0, then what I'm seeing is x squared over 25 is equal to 1, which if you cross multiply, you get x squared is equal to 25, and that means x is equal to plus negative 5. So to see where my graph touches the x-axis, I go to the original equation and make y 0. Then if I want to see where it touches the y-axis, I go to the original equation and I make x 0. If I make x 0, I will see y squared over 4 is equal to 1. That's what I'm seeing. Then across multiply, I make y squared is equal to 4, and that says y is plus or negative 2. So that's how simple it is. So to sketch an ellipse, I will look for where there's 2 on the y and negative 2 on the y. So I've got my 2 there. Let's say that's my 2 and that's my negative 2. Then if I want to know where it touches x, I look for 5 and I look for negative 5. So I get something like that. So an ellipse is supposed to be like a rugby ball, for those who know rugby, or it can be like an egg, or it can be like a watermelon. There are a lot of shapes that look like an ellipse. So that's the shape of my ellipse. So if I sketch it, I see something like that. So this is my x equal to 3. That is the shape of my ellipse. So that is my origin, that's my y-axis, my x-axis. Then I must remember where I'm shading. There was a key statement, first quadrant. I'm shading the area in the first quadrant surrounded by the 4 graphs. So I must stay in the first quadrant surrounded by the 4 graphs. So that's where I'm shading. That's where my strip must be. So since my limits are all right from the x-axis, it's obvious that our strip should be a vertical strip. So if I go for a vertical strip, the first graph is the one that passes above the strip. I must label them using y because my strip is vertical. Then the second graph passes below the strip, which is my y2. And my y2 is the x-axis. The x-axis is y equal to 0. So y1, we need to go back to the equation of the ellipse. We make y the subject. So this is another task we've got to do. We've got x squared over 25 plus y squared over 4 equal to 1. I want to make y the subject. So the first thing I'll do, I'll carry this one across. If I carry it across, I'll get y squared over 4 is equal to 1 minus x squared over 25. Then I multiply all through by 4, I'll get y squared is equal to 4 into 1 minus x squared over 25. So that's how I'll prefer to make my y the subject. That's y squared. So from there, if you take the square root, you then see your y. So your y is the square root of 4 into 1 minus x squared over 25. So that's what you call your y squared. And do you see that this is a product? Square root can move over a product but not over subtraction. So the square root of 4 is 2. Then you get the square root of 1 minus x squared over 25. So that is how you can put your y1. So that's our diagram. Now let's go to the volume. The volume, we have to look at the rotation. The rotation is right there, staring at us. X-axis rotation tells us how the formula of volume starts. Then the strip hits the x-axis. Then that means our volume must end with Tx. Then we'll go to page 5 of our N6 formula sheet. We'll search for that formula that starts with Vx, ends with Tx. So it is having pi, the integral of from a to b of y1 squared minus y2 squared. So from there, we start substituting a and b. We read from the x-axis where we started shading to where we stopped. You see, it corresponds to the limit we picked already. So this is pi, the integral from 0 to 3, y1 squared. You see, that's what we're doing. Y1 squared, you see, it has a 4. Bracket that. So y1 squared is 4. Bracket 1 minus x squared over 25. Then y2, it's a 0, so we'll need that. So 4 is a constant. I practice sending out all my constant to make life easy with integration. So this is simply what I'm integrating. 1 minus x squared over 25. So if I integrate that, I will get my x minus x cubed on 75, because when you integrate x squared, you add 1 becomes 3, you divide by 3. 3 times 25 is 75. Then you put your limit, starting with the upper limit, it will be 3 minus 3 cubed over 75. Then lower limit, it's just a 0 minus 0. So that's my upper limit. So what I will simply do is I will take 3 minus 3 cubed. 3 cubed is 27. So I'm taking 3 minus 27 on 75. That gives me 66 on 25. And I'll multiply by 4. So that will leave my answer in terms of pi. It's allowed to leave your answer in terms of pi. So my volume here is 264 over 25 pi. But if you choose to multiply that by pi and get your answer in decimals, it's still fine. That will give you 33,175 unit cube. So that's our volume. So we can now go to the last part. It says calculate the x-ordinate of the center of gravity. So the x-ordinate on page 5 of our M6 formula sheet is defined as volume moment about y over the volume. The volume, we've just calculated it to be 33,175. Now volume moment is where we've got a job. Volume moment about y is the integral of r dv from a to b. dv is the formula that we have just used for our volume. So copy all of it down. So if we are copying all of it down, we start right from pi outside. So that's pi, the integral from a to b. I'll keep space for r, again my y1 squared minus y2 squared, then dx. Then I can now look for my r. My r is defined based on the axis I see there. I must go back to my graph. I start from the center of my strip and move to the y-axis and check the direction of movement. So my strip and my diagram is a vertical one. So I'll start from there and move in a straight line until I hit the y-axis. If you look at that dotted line, you see it's horizontal. Anything horizontal is described using x, especially when the strip is not also in the same direction. So it means our r is a simple x. So I can now start my substitution. My a and b was 0 to 3, y1 squared minus y2 squared. You see we did it here, and we got 4 pi outside. So that's our 4 pi. We get our x. Then inside we get 1 minus x squared over 25 dx. So before we integrate, we need to open the bracket. We get the integral from 0 to 3 of x minus x cubed over 25 dx. We can then do our integral. If you get the integral of x, it gives you x squared over 2. The integral of x cubed, you get x to the power 4 over 4. That 4 will multiply this 25 to give us 100 from 0 to 5. So we can now put in our limit. So if I start with the upper limit, volume moment about y, I get my 4 pi outside. Upper limit is a 3. If I put 3 there, 3 squared is a 9 over 2 minus 3 to the power 4. That is 81 over 100. Then lower limit will simply be 0 minus 0. So for our volume moment, I have to take 9 over 2 minus 81 on 100. 9 on 2 minus 81 on 100. That gives me 369 on 100 times 4 pi. So if I take times 4 pi, that gives me 369 on 25 pi, unit to the power 4. If you put your answer in this house, it's still accepted. It's not a problem. That will give us 46,370. So that is your area moment, volume moment about the y-axis. And therefore, we can get our x bar, x coordinate of the center of gravity. That's what the question is looking for. So x bar is simply 46,370 divided by our volume, what are you? 33,175. So if you do that and divide by 33,175, we get approximately 1,397. We can just say it's 1,398. 1,398 units. So that is our x coordinate of the center of gravity. And if we want to confirm it, we just have to go back to our diagram and confirm that that number lies within the limits where we integrated or where we shaded. You see that we're looking for the x ordinate of the center of this shaded portion, and that portion lies between 0 and 3. So if your center is 1,398, then we are very sure that we are on the right track. So guys, thank you very much. I guess that helps.